Now that we've looked at how to make some graphs for categorical variables in Excel, we're going to look at what can go wrong with graphs. So how do graphs end up being misleading or distorting the data? The areas we're going to look at fall mostly under a category called the area principle, which is related to proportional sizing. So two parts of the area principle that we're going to start with are the area for each part of the graph should represent its magnitude or size. And each part of the graph is sized proportionally relative to the other parts of the graph. So if I have a category that represents 10% of my data, I have another category that represents 20% of my data, that 20% piece, the slice of the pie or the height of the bar should be twice as much as the category that only had 10%. So that's kind of what that's saying. So let's take a look at some examples of this. So this graph we have in the middle is titled, "What are your plans after high school?" Students were given four choices: attending college, entering the workforce, joining the military, or taking a year off. So let's start by looking at these two bars in the middle, entering the workforce, which is 3%, and joining the military, which is 1%. So eyeballing these, I definitely have a problem here because this third bar over, this yellow one, looks like it's probably closer to 2.5% rather than just 1%. That bar should be quite a bit lower. So that's a little bit concerning. Let's add in this bar all the way on the right. So taking a year off is 5%. And that 5% compared to the 3%, that seems okay. So it's a little bit concerning, but not too bad until I go back and look at this first bar, this one that's titled attending college, and it's 91% of the students said that. So that's 19 times more than this 5%, so the next closest category. So this bar should be 19 times higher than the green one. And instead, what happens is if you don't read those numbers and you just eyeball the bars, it looks like the number of students attending college is about the same as the number of students taking a year off. It's only if you read those numbers that you see what that difference really is. Okay, so that would definitely be misleading. This graph on the right, this one's also from an educational institution. This one's from a university, not Western, but somewhere else. And it's titled Steps to a Healthier You, and it counts the number of steps from the Ohio Union to other campus destinations. So the first bar on here is 1,136 steps. That's to get to RPAC. That's fine. But let's look at the second bar. So if I just eyeball this, if I don't read any of the numbers and I just eyeball this, it looks to me like this second line that goes to Thompson Library is almost as long as the first one. So if I was guessing, I'd say, oh, maybe it's about 1,000 steps to Thompson Library. Now, if we go look at the number, what we'll see is that it's 797 steps. So that seems a little bit off. Like I would have expected that bar to be shorter. Well, let's keep looking. The third one, center of the oval, that's in that kind of green color, says 498 steps. So it's about half of the distance of the other two, just numbers wise. And it looks like it's maybe the bar itself is about half of that distance. So that seems okay-ish. But where I really have a problem is this last bar on here that's titled Oxley's. It's actually the furthest distance from the Ohio Union. It's 1,196 steps. So it should be the longest bar on here, but instead it's the third longest. So it's shorter than two other bars. So this graph is also very misleading in terms of those bars are just not sized relative to each other. And looking at that, I would think, oh, Oxley's is not that far of a walk when really it's the longest walk. All right, come back in the next video and we'll look at some more ways that people mislead with graphs.